Let's continue with problems and examples for chapter 5. In previous video we were discussing the parallel circuits are considered current divider. So it is important to know how to do current divider properly. There are two ways we can do current divider. There is the general form where we can find any current in any branch of the circuit once we have the total current, the total resistance of the circuit, and we have the I total. Or there is a special format where we have only two different branches. We have two resistors that will only give us I1 and I2. So this is useful when we have two values, two resistors only, because we don't have to calculate the R total, which we know it is very complicated to calculate. But if we have more than two branches, it is just time efficient to calculate the R total. So depends with what we have. That's how we are we decide what is it that which formula we use. But this is the general formula where we say that the R total is divided by the resistor that we are interested multiplied by the total current. That will give us the current that we are interested in. If we have only two branches, then it will be the opposite resistor over the sum of the two resistors times the total current going into those two branches. So in this case we have three branches, so we are going to use the general form. So I have my I source, I have my I1, I2 and I3. Keep in mind, we usually label the currents, powers and voltages as the resistor is labeled. So if this is R1, it's going to be I1, B1, P1. If this is R2, it's going to be current 2, power 2, voltage 2. Okay, and that's how we continue here. So the R total, we are going to say 1 over the reciprocal of the sums. That's going to give us 111 ohms. Then I want to find my I1. I will just have to get my R total, we are already calculated to be 111 divided by R1 multiplied by my I total. In this case, I can go and find I1, I2 and I3 just by changing the denominator, because the numerator stays the same. You see, for I1 is 111, for I2 is 111, R1 value is 680, for I2 value is 330. The current stays the same, so we can say that what we are doing is just getting a ratio of the value of the resistor compared to the total value. So that's what we're doing. So we get that I1 was 680, we get 1.6 milliamps, I2 was 330, which is less than half of this, so we expect that the current is going to be more than double, and it is. And then I3, it was 220, so most of the current is going to travel to I3. So that's how you would calculate the different currents by using the current divider rule. Okay, note that you don't need to use Ohm's law here. You could use Ohm's law, but you needed to find the voltage. You can find the total voltage, which is not given to you, but you could find it. You have the total resistance and you have the total current. So using Ohm's law, you can find them. You can multiply them across, and then you find it, and then you use Ohm's law to find the currents. But why to do that when we can use the current divider? Power in parallel circuits. The power in parallel circuits is the same as it was described in series circuits. The summation of each individual power in each individual component is going to add up to the total power. These are the different definitions of power. So most likely the one we are going to be using is voltage squared over R, because most of the time in a parallel circuit we will know the voltage. So right here they are giving us a circuit, excuse me, and they want to find P1, P2 and P3. So we find P total to be B squared over R total, or I squared times R total. So either way we need to find R total. So let's find R total right here. So it'll be 1 over the sum of the reciprocals. So I get an R total of 11.05 ohms. So from here I can find, I don't have my voltage, so I use the definition of I squared times R total. I have my I squared is given to me 200 milliamps, and R total I found to be 11.05, so I get a total of 442 milliwatts. From here I can find my voltage source, saying that P total is over I total to be 2.21 volts. Then I'm going to find my P1, B1 over R1, which is 2.21 divided by my resistor, my R1. So you see the voltage B1, B2, B3 are all the same, and they are going to be squared. What is going to be changed is the value of the resistor. So the lowest the value of the resistor, the higher the wattage, right? That's expected, because the current that goes through the smallest resistive pathway, in this case being 22. And then if I add them up, I will get, if you would add them up, you will get 442. So let's do that. So it's 71.83 plus 148 plus 222. I get 441.83. Pretty close. A little bit of error there, but that's just because of the approximation that we are doing. In this problem, we are going to calculate our total. We have 1, 2, 3, 4, 5 different values. If we have the same value of resistor across in the parallel circuits, we are going to be able to use this special formula where what it says that we have the R value divided by the number of the resistors that we have. So in this case, we have the value of the resistor is 300, and the number of branches we have is 5. So the R total is 60 ohms. Pretty sweet, right? And that concludes our practice, example, and problems for chapter 5.